The Unijunction transistor is a device that has very poor amplification ability. It consists of an emitter material that is placed just off center. That is a P-type material, and then it has two bases, base 1 at the bottom, base 2 at the top, and those connect to an N-type material. And then as a result we will have a depletion region around that PN junction. Now if we break down the construction, we realize that technically, if that's our emitter, that connects to a diode, and then we will have two resistances that make up the main conduction N-type channel. This N channel is lightly doped, and if we look at the configurations, resistance 1 and 2 are almost the same, with resistance 1 slightly greater than resistance 2. So R1 is slightly greater than resistor 2, but they are almost equal. Together they have a typical resistance in the range of 10 kilo ohms. The symbol for the Unijunction transistor we've got the base, we've got the emitter, then we've got base 2 and base 1. And the characteristic for the Unijunction transistor goes in line with the actual operating circuit, or the circuit in which we find it, which is a spike generator or a ramp generator. That peak point over there will be that's a voltage across the emitter and base 1. That distance over there is 0.6 volts, and that point there is indicated as my trigger voltage. Below the peak voltage over there we've got our cutoff region. That point there is my valley point. Above that level we've got saturation, and then this section in the middle there is my negative resistance region. It's called the negative resistance region because my current flow through the emitter decreases, well, current flow increases while the voltage decreases. Now, looking at this configuration or this characteristic along with the basic construction, we can see that this voltage across there starts off in the reverse bias state. As I increase the voltage, I'm going to get to a point where I've got 0 volts across there. When I go 0.6 volts above that 0 volt level, that is when I reach my peak voltage. At that point, this depletion region falls away and I get current flow through out of the emitter. As a result, my current flow, this is no longer an N-type material, and that's no longer a P-type material because it is conducting, and as a result there is a spike in the amount of current that can flow. Looking at the application circuit, we have a positive voltage that will connect to a resistor along with a capacitor. Now when we've got our two resistors on the output, I can measure my voltage on either the top resistor, or I can measure my output on the bottom resistor, depending on the direction of the spike that I want. That emitter connects to the division point between the resistor and the capacitor. When I connect this circuit, this voltage on the capacitor is going to increase because it is charging through the resistor. So that voltage increases. That means that the voltage, or the total voltage across the resistor and the base emitter junction over there, increases. During that time, there's no change in the amount of current flow. As a result, my current, or my voltage that is developed on this resistor, will stay constant, the same with that one over there. When this capacitor reaches the point of that voltage plus 0.6 volts, then the emitter base junction here will allow conduction, and as a result it will become forward biased. When it becomes forward biased, we now have a parallel conduction flow taking place. That allows this capacitor to discharge through this resistor up, and the current will then separate through that resistor as well as that resistor. So while the capacitor is discharging, I will get a brief spike in the amount of current, and as a result I will get an increase in the amount of voltage that is generated on this resistor. This resistor, on the other hand, we will find that there is a sudden decrease in current, because, remember, Kirchhoff's law says the sum of all the voltages in a series circuit must equal the supply. If this voltage increases, then this voltage has to decrease, and that's why we get that negative spike there. This positive spike is due to the increase in the amount of current flow. Once this capacitor has discharged, this base emitter junction will cause a depletion region to be reformed. That will in turn return the current flow through this half of the circuit back to normal, and as a result the voltage on these two will be normal again.